Investigation 3 has 3 parts. The first part is on multiplication patterns, and that has to do with area as well as squares and square roots. Let's go ahead and look at multiplication patterns first. And what I have drawn on the board there are 2 rows of marks. Those would be that whole series of marks. We'd call that an array. And basically there are 2 rows and 5 columns. And that's what we call an array. A group of rows and columns. That's what we call an array. Now, what does that have to do with multiplication patterns? Well, think about it. We have 2 rows and 5 columns. You could just count and see that there are 10 marks there, but if you multiplied the rows by the columns, you'd also see that that equals 10. Or if you multiplied the columns by the rows, of course that equals 10 as well, because the order that we do multiplication, it doesn't matter. 2 times 5 is the same thing as 5 times 2. Why don't you draw an array that has 3 rows and 4 columns? Well, that's what it would look like. And you could also do multiplication there. 3 rows and 4 columns. 3 times 4, that equals 12. You should be able to count those dots up, and that equal 12. So an array, that can be used to model multiplication. It's a model of a multiplication problem. It's just using boxes or dots or tick marks or X's, just whatever. Now, what does that have to do with area? Well, area is a measurement of something. Maybe you remember in Investigation 2 we studied perimeter. Perimeter is measuring the distance around an object. Our first example in Investigation 2 was of a rectangle. Let's do a rectangle again. Now, perimeter is distance around. The area is the amount of surface that an object has. So this rectangle has a certain amount of surface to it. Maybe you've done some painting, like painting a house, and on the side of the can it'll tell you that this paint will cover 200 square feet of surface. And that's what you're doing when you're painting, right? You're covering a surface. Or maybe you've put tiles on a wall or tiles on a floor, and each one of those tiles has a certain surface to it, and what you're doing with those tiles is covering a surface. Well, let's say this rectangular surface here, we wanted to cover it with tiles, and so we go and buy these tiles. They're all the same size, and let's say that they were shaped like squares, so we could break this area up, and it happens to break up into what looks like an array. It has 2 rows and 4 columns. And let's not concern ourselves with units right now. Let's just say that these sides had a length, or these squares had a length of 1, a length and a width of 1. Actually, it might be better to use some units just to help us understand this. We'll say that they are 1 foot by 1 foot. And so what that means, let's just draw one of them over here. A 1 foot by 1 foot tile that has an area of 1 square foot. That's what we would say. It has an area of 1 square foot. And we might abbreviate that 1 SQ period FT period. Now we can easily see there by thinking about arrays, we have a 2 row by 4 column. That equals 8 squares basically. And since each one equals a square foot, that means that the total area of that rectangle is 8 square feet. That's how we write our units for finding area. You always have that SQ for square, and then if it's inches you'd say IN, if it's feet like this one FT, centimeters cm, but you always precede it with the word square. Now look at that rectangle that I've just drawn. I've broken that into squares that are tiles, you could think of, that are all 1 square centimeter. That one at the top is 1 centimeter by 1 centimeter. So what is the area of that rectangle that I've drawn? How many tiles does it take to fill it up? Well, you just look at that, 5 rows and 2 columns, so that'd be 5 times 2 is 10. 10 tiles, 10 square centimeters. Since that's broken up into squares or square centimeters, there's 10 of them. 10 square centimeters. That's the area of that rectangle. If that was a rectangular surface and we wanted to cover it with 1 centimeter by 1 centimeter tiles, it would take 10 of those tiles, or 10 square centimeters worth of tiles, to fill that area. A lot of times tiles on a floor are 1 square foot in size. You might even go get your ruler out and see if you have some tiles somewhere, maybe in your kitchen, that are 1 square foot in size, 1 foot by 1 foot. You could count all those tiles and figure out the area of your kitchen or whatever surface it was. Now, we've talked about multiplication patterns, area. Now let's talk about squares and square roots. That has to do with area. For example, let's draw a square, and let's say it was 2 inches by 2 inches. And how many squares could we break that up into? Well, just think about it. We could break that up into 4 of them, or 1 inch by 1 inch, right? We'd say that that has an area of 4 square inches. A square, that's a type of rectangle whose length and width are equal to each other. This rectangle that we've drawn, its length was 2, its width was 2. Both of those are equal to each other. Then the small squares that we broke it up into, those sides are equal to each other as well. And think about it. Think about the small ones. They have an area of 1 times 1 equals 1. And then our bigger one had an area of 2 times 2 equals 4. We call those things perfect squares. 3 times 3. The same number multiplied by itself. That's called a perfect square. 3 times 3 is 9. 4 times 4 would be next. That's equal to 16. Why don't you write down the perfect squares for 5, 6, and 7? Well, 5 squared, or 5 times 5, that's 25. 6 squared, or 6 times 6, that's 36. 7 squared, or 7 times 7, that's equal to 49. We call those perfect squares. A number multiplied by itself, that's called a perfect square, or a square number. Now, a square root, that's a little bit different. It's kind of going backwards. If you had 49 and you want to know what the square root of 49 is, you would just say it's 7. If you look at 36, you want to know what the square root of that is, it's 6. The square root of 25 is 5. The square root of 16 is 4, and so on. And to talk about a square root, instead of writing out the words square root, we use this square root symbol. And so if you saw the square root of 9, you would know that that equals 3. The square root of 9 equals 3, because you think of what two numbers that are equal to each other, if you multiplied them together, would be 9. Well, that would be 3, right? 3 times 3 is 9. The square root of 9, we say, is 3. See if you understand this. What is the square root of 4? Just write that down. You just have to think to yourself, what two numbers multiplied together would equal 4? Two similar numbers multiplied together. That's very important. Well, 4 times 1, that equals 4, but those aren't similar. Those aren't equal numbers. 2 times 2, that equals 4. So the square root of 4, we would just say, is 2. We don't say it's 2 times 2. The square root is just one number. So we just write down one number. And a lot of times in mathematics, we use symbols to help us explain something. So that's what the square root symbol is explaining. It's saying what is the square root of this number inside. That whole sentence, what is the square root of the number inside? That is explained just with one symbol, the square root symbol. Why don't you do one more? What is the square root of 81? Well, 9 times 9 equals 81, so the square root of 81 is 9. Okay, well that's all for investigation 3.